This is a video for E123 final project by Henry, Shengyu, James, and Johnny. This is our workflow diagram inspired by JPEG 2000, which uses wavelet weight quantization. For our input representation, rather than sending all the frames naively, we will actually keep the first frame but fill the rest with RGB differences, which we call residuals. And this will allow for more sparse representation of the input. And then once you get the image data, we're going to apply some forward transformation that will help with sparsity and compression. Specifically, we'll first convert RGB channel to luminous chrominance channel, downsample and upsample using FFT, and then use wavelet with W4. And after that, we then quantize the result to int A to compress image size, and we also threshold the lower values to have more sparse representation of image for a better compression ratio. The actual compression we use in the entropy encoding part is LZMA compression, and we will pretty much zip the compressed image data and its metadata information for our actual final transmission. Once we receive the data, we'll perform corresponding inverse transformations, and in the end, we'll use bilateral filtering for video post-processing, which helps to reduce ring artifact in the image. Finally, we then stack the frames together to reconstruct the video. We also tried utilizing the digipeater field to store more information and reduce overhead, but we couldn't get it working to correctly decode the package.
Here we show our transmission results using our algorithm. For these examples, one can notice the significant improvement in PSNR and visual quality from the baseline method.
Now we show our transmission results using our algorithm. Given an input video, we ran wavelet encode.py to actually get the compressed data. So we store our video content, compressed video content, into a pico file, and the metadata into a text file, and have a zip on the two files. So we are able to compress the zip file into 6.6 kilobytes, which allows us to transmit the zip file within 75 seconds.
Now we want to decode the packets from what we've encoded. And here are the codes that we've reused from Lab 5. Here are all the decoded packets. And now we want to check whether or not our decoded packets are similar to the test. So we do this by checking if the bytes are similar. And here we've seen that the bytes are pretty much the same, exactly the same. And now we try to reconstruct the video. Yeah, so our PSNR is 20.135. And here, this is the animation.png, which is the reconstructed video.
I should have went for a winter vacation. Instead of staying in Berkeley for research for nothing.